Evaluating a system of linear equations with three equations in three variables is very similar to the two-variable case, except that we actually have to do a little bit more work. But you'll see we reduce it down to the two-variable case. So let's say I give you a system of equations. The first equation being x plus 4y minus z is equal to 10. The second being 3x plus 2y plus z is equal to 4. And finally the last one, 2x minus 3y plus 2z is equal to minus 7. Now for clarity's sake, let's label all of these equations. So we're going to call the first equation 1, the second equation 2, and predictably the third equation we're going to call 3. So now the goal is for us to pick two different pairs of equations and get rid of one variable. The same way that we do it in the two-variable case, except that in this case we pick two different pairs. So first thing, we should decide what variable to get rid of. Now I would rather get rid of the z's just because they've got the smallest coefficients, and as it turns out, if we add 1 and 2, the z's cancel out automatically without us doing any extra work, which is sort of what we want. So I'm going to first add equations 1 and 2. So the x plus 4y minus z is equal to 10 is equation 1, and then 3x plus 2y plus z is equal to 4. That's equation 2. Now adding these two together, we get 4x plus 6y. The z's cancel out, and that's all equal to 14. Now let's label this equation 4 so that we don't get confused. Now that we picked 1 and 2, we pick another combination. So we pick either 2 and 3 or 1 and 3. Now note that if we pick 1 and 3, all we have to do is multiply the top equation by 2. Whereas if we pick 2 and 3, we have to multiply the equation 2 by negative 2. And since it's better to deal with positive numbers and negative numbers, I think 1 and 3 is our best bet. So for 1, let's multiply 2 times equation 1. So multiplying the top equation by 2, we get 2x plus 8y minus 2z is equal to 20. I just multiplied every single term by 2. And then I'm just going to write equation 3 as it is. We don't need to change it. So we got 2x minus 3y plus 2z is equal to minus 7. So now when we add them together, we get 4x plus 5y, and then the z's cancel out, which is exactly what we wanted. And this is all equal to 20 minus 7, which is 13. So now let's call this equation 5. Now I want you to know that if you look at equations 4 and 5, they're both a linear system in two variables, which we already know how to solve. So let's rewrite these equations as so. So we get 4x plus 6y is equal to 14 as our first equation, and then we get 4x plus 5y is equal to 13. And now all we have is x and y, so we got two equations and two variables, and so now we know how to solve. So first thing, we choose to get rid of a variable. It looks like the x is the easiest to get rid of. So if we multiply one of the equations, let's say the bottom one, multiply it by negative 1, we're going to get a minus 4x as the coefficient, as the x term. So the x's will be able to cancel out once we add them together. So let's do that. On the top, it stays the same. So we got 4x plus 6y is equal to 14. And then on the bottom, all we do is just where there's a positive put a negative, where there's a negative put a positive. So we got minus 4x times minus 5y, equals minus 13. So now, Adding it all together, the x's cancel out and give us 0, which is exactly what we wanted. And then we got 6y minus 5y, which is just 1y. And then 14 minus 13 is just 1. So now we've solved for y. And let's highlight it here to denote our success. So now we've solved for y. And now we need to solve for the other two variables. But no, we can plug y equals 1 into either equation 4 or 5 to solve for x. So let's do that. So let's pick an equation. I'll put it into the first one. So I'm going to plug y equals 1 into the first equation, which is 4x plus 6 times y, which is 1, is equal to 14. That means 4x is equal to 14 minus 6, which is 8. And so x is equal to 2. Great, that wasn't so bad. So now we found x and y, but remember we have 3 variables. We're left with z, so we need to solve for z. So the way we do that is to plug x equals 2 and y equals 1 into either of the 3 original equations. So into 1, 2, or 3. Now let's remember what these guys are. So we have 1, 2, and 3. So generally you pick the equation that has the lowest coefficients or that will cause the least amount of work. That looks like it might be the first one. So let's plug x is equal to 2 and y is equal to 1 into the first equation. So we got x plus 4y minus z is equal to 10. I'm just rewriting it for clarity. So now plugging in, we got 2 plus 4 times y, which is 1, minus z is equal to 10. That means 6 minus z is equal to 10. So minus z is equal to 10 minus 6, which is 4. And dividing both sides by -1, we get that z is equal to -4. So now we have all our 3 variables, and the way to express the solution is in terms of the ordered triple. Just like in the 2 variable case, it was expressed in an ordered pair. So we want to say the solution to this system is the ordered pair x comma y comma z. So 2 comma 1 comma -4, and that is our solution.